Welcome back for the fourth and final video of our logarithm review. In this video, we'll be doing some word problems on growth and decay. Cobalt, an element used to make alloys, has several isotopes. One of these, cobalt-60, is radioactive and has a half-life of 5.7 years. Cobalt-60 is used to trace the path of non-radioactive substances in a system. What is the value of K for cobalt-60? K is the growth or decay constant. In this case, we're talking about a half-life, and that is decay. And that is the percent at which it decays, the rate of decay or the rate of growth. So for science prefers this particular formula for growth or decay with a negative here. That is decay. Y is the ending amount. A is the starting amount. E is a constant. K is the percent or the rate of growth or decay. And T is the time. So we're talking about the decay through a half-life. That half-life is 5.7 years. No matter how much I start with, I'm going to end with half of that after one half-life. So if I start with 100, at the end of a half-life, I'll have 50. Let's make that simpler. If I start with 2, at the end of a half-life, I'll have 1. So 1 equals 2 times e to the negative k times 5.7 power. If I divide both sides by 2, I'll get 1/2 equals e to the negative 5.7 k power. To cancel out this e, I can do natural log on both sides. That's log base e, and that cancels the e. So I've got natural log 1/2 equals negative 5.7 k. And then to get k by itself, I can divide by negative 5.7. So k equals natural log 1/2, or 0.5 will do, divided by negative 5.7 is 0.1216. So k is 0.1216. Or you could say it decays at a rate of 12.16%. Next, how many days will it take a culture of bacteria? So this is another scientific one. This one is growth, though. We are increasing. So we're going to use a very similar formula, but this time it's going to be positive in our power here. So it's increasing from 2,000 to 50,000 with a growth rate of 93.2%. So the ending amount is going to be 50,000. The starting amount is 20,000. There's 2,000. K, the growth constant, is 93.2%, or 0.932, and we want to know how long will that take. So what is the time? So 2,000 equals, sorry, that's not correct, 50,000 equals 2,000. So our ending amount equals the starting amount times e to the kt, 0.932 times t. So if we divide by 2,000, 50,000 divided by 2,000, and we've got 25. So 25 equals e to the 0.932 t power. To cancel out that e, we can do natural log on both sides. So we have natural log 25 equals 0.932 t. And then to get t by itself, we can divide by 0.932. So natural log 25 divided by, close those parentheses, divided by 0.932 is 3.4537. 3.4537 days, so just about 3.5 days. Next, we are going to have interest compounded continuously, and that's this formula, y equals PE to the RT, where y is the ending amount, P is the starting amount, R is the interest rate, and T is time. We're depositing $35,000, so that's P, the principal or the beginning amount. How much money will we have in the end? So that's going to be Y. That's our variable. Our interest is 1.35%, 0.0135, and it's over 15 years. So we have Y equals 35,000 times E to the 0.0135 times 15 power. Now I can just type this in my calculator, 35,000 times E to the 0.0135 times 15 power, and we'll have $42,856.10. I actually wrote the wrong formula here, so we're going to ignore that. It's using the same information above, so it's looking back to this problem here. So we're going to be using y equals PE to the RT. How long will it take your money to triple? So if your money is going to triple, then in the end, you're going to have 35,000 times 3, which is $105,000. P, the beginning amount, is 35,000. R is 0.0135, and T is unknown. So 105,000 equals 35,000 times E to the R times T, 0.0135 T. Okay, so we will divide by 35,000, so 105,000 divided by 35,000, we should know this is going to be 3, equals E times 0.0135 to the T, times T. Natural log on both sides will cancel out the E, so natural log 3 equals 0.0135 T. And we'll divide by 0.0135. So we have natural log 3 divided by 0.0135, and we get a mistake is what we get because I didn't close my parentheses. Natural log 3, close the parentheses, divided by 0.0135 is 81.3787 years. Probably not the best investment you'll ever make at 1.35%. That's going to take an awfully long time to see that money triple. A city has a population of 636,254, and it has been declining by a rate of 0.21% per year. Predict the population of the city after 15 years. So this is exponential decay. Okay, so this is not quite scientific like bacteria or half-lives of an isotope. So we use this formula. If it was growth, if it was growing by 0.21% per year, this would be a plus. That would be the only difference. So Y is the ending amount, and that's what we don't know. A is the starting amount, which is 636,254. Then we have 1 minus R. R is the interest rate, or not the interest rate, the rate of growth or decay, and that's 0.21%, so 0.0021. And T is time, and that time is 15 years. So Y equals 636,254 times 1 minus 0.0021 to the 15th power. So I'll type that in my calculator, 636,254 times 1 minus 0.0021 raised to the, I need to close those parentheses, raised to the 15th power. And we get 616,503.9522, but you can't have a decimal of a person for your population, so we will round that to the nearest whole person. So that 0.9522 will bump that up to a 4. So we're going to predict that there will be 616,504 people in this city after 15 years.